Here's a little review on exponential functions, growth, decay, and compound interest. The first two at the top are examples that I will walk you through to help you with number 2 underneath. So in the first one we have an XY table. We have our X values going up by 1 from 0 to 7, and our Y values are also going up. We have 4/10, 6/10, 9/10, 1 35 hundredths. But let's see, is that an exponential or is it linear? And what we need to do to figure out is there a common difference or is there a common ratio? So looking from 4/10 to 6/10, if I add 2/10, I'll get 6/10, but if I do 6/10 plus 2/10, I won't get 9/10. So I don't see a common difference. So right now it's not linear. So how am I going to figure out if there is a common ratio? Well, one thing I can do is I can go ahead and take my 6/10 and I can plug it into my calculator, and I've got 0.6, and I can divide it by 0.4, and I'm going to get 1 5/10. I can do the same thing with 9/10 to 6/10. If I divide those two, 9/10 divided by 6/10, will I get 1 5/10? And I do. If I take 1 35 hundredths and divide it by 9/10, I will also get 1 5/10. So I do have a constant ratio. And now what I have to do is I have to remember that my formula. So I had the y was equal to the initial value. So that was my 4/10. So it's 0.4 multiplied by the common ratio, which is 1.5, and that's raised to the x value. You can always double check your work by taking any one of these x values. You can work with that xy, and you can take 1 5/10, raise it to the third power, and then multiply it by 4/10. You should get 1 35 hundredths. Let's take a look at the second example. So if I'm looking here, I can see my x's I'm going up by 1. Here I am going down by 5. And I can tell that it is happening throughout. So this is a linear function. So we have y equals, remembering that my common difference, that's my rate of change, it's going to be -5. And if I go right up here, 0.40, that is my y-intercept or my b. So it's -5x plus 40 is the equation here, the function formula. So you're going to do the same thing for 2a, b, c, and d. Say if it's linear or exponential, and then write the formula just like we did here. The second page has the compound interest formula. If you deposit $6,500 into account paying 8% annual interest compounded monthly, annual, what will you have after 7 years? And then down here is another one, 14,000 multiplied by 92 hundredths raised to the t power. Is this growth or decay? The initial value, what's the rate? And then find the value of the car after 3 years have passed. The car's worth 14,000 now. This is just a little review before we start off with geometric sequences next class.